I've always been skeptical about the various pellet shapes and the claims about these pellet shapes. Sort of like pointed pellets with better penetration and hollow points with more muscle damage or tissue damage when you go hunting. So I've decided to check this out and test the various pellet shapes to see how they penetrate and the damage they cause. So I've assembled a couple of pellets, wad cutters, dome pellets, pointed pellets and hollow points, and I'll be shooting them through a .177 brake barrel 1000 feet per second rifle, a standard powered .22 PCP and a high powered .22 PCP. We'll be shooting at clay like this, and then we'll see how far they penetrate, how far the pellets penetrate and what damage they cause. Now this clay is quite dense. This ball, as you can see here, it's not very large, but it weighs almost 1.5 pounds or 650 grams. And when I initially made it and I tested it, I started off with just seeing what a Daisy Red Rider would do, and I was quite surprised to see that the Daisy Red Rider, the BB didn't even penetrate. So it's quite tough. So we'll see what happens when we shoot proper air guns and real pellets through it. You will see that the pellets used for the PCP rifles, the .22s, are fairly similar in weight to ensure similar muzzle energy. For the .177 brake barrel, I didn't worry about getting pellets with similar weight because the brake barrels have similar muzzle energy regardless of which pellet you use. It may vary a little bit, but it's sort of in the same ballpark. We'll start off by using this .177 Crossman Fury NP. It's a nitrous piston gun and it is rated at 1000 feet per second. this picture, I have summarized the results of the .177 brake barrel. The entrance wounds are at the bottom with the exit wounds at the top, and it is clear that without exception the entrance wounds are much larger than the exit wounds. The wad cutter caused the most damage at the entrance, followed closely by the hollow point, but the hollow point has a more significant exit wound as compared to the wad cutter, and therefore seems to be the pellet causing the most general damage. So I have to admit that I was wrong. Pellet shapes do make a difference. However, I doubt that there is any deformation of the pellet while traveling through soft tissue, probably because the energy produced by a brake barrel is too small to create any mushrooming unless the pellet hits something solid. So, in summary, it would seem that for a brake barrel .177, the damage is not caused by mushrooming at all, but rather by the shape of the pellet pushing through the soft tissue. Our next rifle is the Predator, based on the SPA PR900W. It's a about 26 foot-pound PCP in .22 form, and this will then represent the lower powered PCPs, and to see whether they perform differently than the higher powered ones. As with the .177 brake barrel, this medium-powered .22 PCP caused larger entrance than exit wounds. However, the difference in size is not as big as with the .177 brake barrel. The pointed pellet seems to cause slightly more damage than the domed pellet, but the hollow point is interesting. The entrance wound is much larger than the exit wound, and it would seem that the pellet lost most of its energy when entering the clay. I also think it caused a fairly large wound cavity during the entrance, which then collapsed in on itself. During the loss of energy when entering the clay, the pellet lost most of its velocity and then traveled fairly slowly through the rest of the clay, creating a very small exit wound. This hollow point would probably not be suitable for hunting larger game with this specific rifle, or rather rifles in this power range, as it would probably not be able to penetrate deep enough to cause significant damage to the vital organs. I was a little bit surprised by the results of this specific test, and I think I would recommend pointed pellets if you'd like to go hunting with a .22 PCP in the mid-20s power range. And finally, we'll shoot this high-powered JK Hondo Blessed Bullpup in pin 22. This gun is a 50 plus foot-pound gun and should give us a really good idea of what can be done with high-powered air rifles in small bore examples. The hollow point transferred so much energy to this 1.3 kilogram ball of clay that it and the coffee tin that it stood on toppled over and it fell on the ground. This fall distorted the clay, so I was unable to determine which was the exit and the entrance holes in the piece of clay, but it seems to me as if this may have been the entrance. So in spite of the fact that I was unable to take photographs of the entrance and exit wounds, it is clear that this hollow point pellet had the most energy transfer by far from the three pellet shapes that we have tested. Okay, when I planned this test, I thought that I could use the clay to test penetration, but unfortunately that wouldn't work. Obviously, I couldn't use the clay for the .22 PCPs, but I thought that by combining the two smaller balls of clay, it may be large enough to test the penetration for the .177 brake barrel. But with both the pointed and the wad cutters, the pellet went straight through the large ball of clay, so I didn't bother to try the others. So I guess I will have to make some ballistic gel and test the penetration with that at a later stage. So here we are. I've made ballistic gel. I would have liked to make a larger piece so that we can also test the .22 pellets, but I didn't have enough gelatine. Also, this block may not be necessarily correctly calibrated, but it will still give us a good idea of the penetration of these pellet shapes when they go through the ballistic gel. Unfortunately, I had some technical problems and I couldn't take video of the penetration test. Well, actually, what I did was I did take video clips, but only noticed afterwards that the video card was full, so there's nothing I can do. But I think we'll give it a pretty good idea of the penetration, as we will see in a moment. These results would seem to correlate very well with the results that we got with the clay tests. Both the wad cutter and the hollow point penetrated about 6 inches into the ballistic gel. This would suggest that they both lose a lot of energy when they enter the gel, and also would explain why they caused such a lot of damage when they went through the clay, with most of the damage occurring when they entered the clay. The pointed pellet penetrated approximately 11 inches. That would also correlate with the clay test, where the pointed pellet did cause a lot less damage than the wad cutter or the hollow point, but it did cause a little bit more damage than the domed pellet. The domed pellet went straight through the 30 centimeter block of ballistic gel and obviously transferred the least amount of energy when going through the gel, therefore enabling it to penetrate straight through. This would also explain why the domed pellet caused the least amount of damage when going through the clay. So, what can we learn from this? We'll look at that in a moment. So which pellet should we choose? Please remember, these tests were only testing the damage and penetration caused by the pellets, and different guns with different barrels may require different pellets for accuracy. So you'll have to test that yourself. I cannot recommend specific pellets for as far as accuracy goes. So these recommendations are obviously for hunting, where penetration and damage caused are the important factors other than accuracy. Even a fairly powerful break barrel won't have enough energy to cause significant tissue damage. So you should rather aim for penetration in order to reach the vital organs. That's the only way you'll be able to really kill something, by shooting it through the heart, causing it to bleed and will die pretty quickly. So if you'd like to hunt anything larger than sparrows or pigeons, you need to use a domed pellet and make sure your shot placement is in the kill zone. But on the other hand, I'm not sure that you use your 1000 feet per second break barrel rifle to shoot anything larger than pigeons with. The pellets from a medium powered .22 PCP air rifle seem to behave much the same as those from a 1000 feet per second break barrel. So in this case, I would also recommend that you use a domed pellet where you would get better penetration, because it seems as if the amount of energy transmitted to the object you are shooting at is not really adequate to cause that much damage. When using a high-powered .22 PCP, penetration should not be a problem, and you should aim to get the maximum tissue damage. When looking at the test done with the clay, the hollow point caused the most damage by far, transferring the most energy. So these would be my pellets of choice if I go hunting with a high-powered PCP air rifle. I have learned quite a lot through the course of these tests, and I hope you did too. So just keep watching SA Air Gunner, and hopefully we'll be able to bring you some more interesting videos in the not too distant future. Keep watching.